Welcome to the Explainer. Okay, so today we're diving into a massive, and I mean absolutely massive shift happening right now in artificial intelligence. We're looking at how AI memory is transitioning away from just simple semantic search and evolving into these complex, truly cognitive architectures. If you've ever felt that frustration of feeling like you're starting from scratch every single time you open a new chat window with an AI, well, you've experienced the continuity problem firsthand. Today, we're going to see exactly how systems like SmartMemory are finally solving it. Let's just kick things off with the ultimate question when it comes to the future of AI companions. What if your AI actually remembered everything you ever taught it? Think about all that friction constantly having to re-explain your preferences, your past projects, or even your specific coding style. That lack of persistent context is what experts call the continuity problem. Honestly, it's the main barrier keeping AI as just a simple tool, rather than a true cognitive partner. And this is exactly what the smart memory architecture documentation gets at. Solving this continuity problem fundamentally transforms an AI from a collection of isolated, one-off responses into an ongoing relationship. It enables agents to remember past conversations, learn from experience, and actually build knowledge over time. So instead of getting total amnesia between sessions, your agent can recall what happened yesterday, last week, or even last month. Its understanding literally deepens the more you interact with it.
All right, here's a quick look at our roadmap for today's explainer. We'll map out AI's continuity problem, look at what the latest database research shows, enter the smart memory architecture, discuss scalability through hierarchies, and finally wrap up with the Zettelkasten method for linking atomic ideas.
Starting off with Section 1, AI's continuity problem. To fix this software amnesia, we actually need to take a page out of the computer hardware playbook. Researchers over at the Stanford VLSI group figured out a long time ago that creating scalable memory requires a multi-level hierarchy. You just can't have one massive, blazing fast memory block. It's physically and economically impossible. Hardware solves this by creating the illusion of large, fast memory through hierarchical levels. Think of a small, super-fast L1 cache right next to the processor, backed by a larger but slower main memory. This principle of layered, specialized storage, that's a foundational lesson AI architecture absolutely has to adopt to solve its own scaling issues. Moving right along to Section 2, what the research shows. So if we look at how the Neo4j GraphRag pipeline tackles this, it essentially takes massive amounts of unstructured text, think giant documents or endless chat logs, and breaks them down into chunks. Then, a language model steps in to extract distinct entities and relationships, summarizing them into a highly structured knowledge graph. Instead of just doing a basic keyword search, this pipeline detects entire communities of closely related entities. This means the AI can suddenly answer broad, highly complex global queries just by synthesizing these community summaries. It's a real game changer. And Fleury's research gives us a really clear comparison on why this matters. Traditional vector RAG relies purely on semantic search, which honestly struggles big time with ambiguity. If you query something like Apple's supply chain, vector RAG might pull up documents about literal fruit agriculture, just because the words match mathematically. But GraphRag, it maintains distinct, typed relationships. It explicitly knows the difference between Apple, the tech company, and Apple, the fruit, because of the edges in the graph, like manufacturer's iPhone versus grown in orchards. It eliminates all that ambiguity before the AI even tries to generate its response. Which brings us perfectly to Section 3, Enter Smart Memory Architecture. Okay, so how do we actually build all this foundational research into working software? Well, Smart Memory uses a hybrid storage engine that combines graph databases, vector stores, and metadata, and it uses all of that to power 5 distinct cognitive memory types. It's actually kind of wild. It practically mirrors the human brain's functional taxonomy. You've got working memory for immediate active processing, semantic memory for timeless facts, episodic memory for your personal narrative experiences, procedural memory for how-to skills, and a Zettelkasten memory for interconnected atomic ideas. By routing information to the right subsystem, the AI isn't just dumping text into a database anymore. It's functionally organizing knowledge exactly like we do. Now on to Section 4, Scalability through Hierarchies. So once you've got all these different memory types, you absolutely need a way to navigate them without the system totally crashing from cognitive overload. We're talking millions of nodes here. Smart Memory handles this by using an evolution algorithm to build step-by-step reasoning flows. It dynamically organizes memory. When the AI needs an answer, it doesn't try to search the whole massive database at once. No way. It traverses from broad domain topics in step 1, navigates down to specific entity relationships in step 2, and then finally retrieves the precise semantic fact in step 3. And this hierarchical approach, it is an absolute game changer for true scalability. Because the knowledge is explicitly tiered, an AI agent can perform structured browsing and multi-level analysis. It can recognize broad patterns across massive data sets, spot gaps in its own knowledge, and even track complex dependencies, like understanding prerequisite skills before it attempts a complex procedural task. Bridging that gap between raw and natural language and these highly structured ontologies usually comes down to 2 approaches. Notice the split here. You've got top-down ontology construction, where you set rigid rules first, and then you have bottom-up schema induction, where the AI organically discovers the structure from the data itself. SmartMemory actually uses a clever hybrid of both, keeping the memory highly flexible but still rigorously organized. And finally, Section 5, Zettelkasten, linking atomic ideas. All right, let's zoom all the way down to the atomic level. Zettelkasten. It translates from German to slip box, and it's a method originally used by human researchers to capture highly focused single atomic insights. In SmartMemory, it's a dedicated memory type where individual ideas are stored and bidirectionally linked. So instead of a rigid top-down folder structure, you get this beautiful emergent knowledge graph where the organization organically arises just from how the ideas naturally connect to one another. But the real magic here is that SmartMemory automates this historically manual process completely in the background. The system continuously runs extraction, pulling entities right out of your conversations. It uses semantic vector linking to find notes with similar meanings, and temporal clustering to group insights from the same time period. It even strategically prunes and merges duplicate notes. There's also this amazing episodic to Zettel evolution that automatically converts your daily transient chat experiences into permanent reusable knowledge notes. And that really brings us to the core philosophy driving this entire architecture. Memory is no longer just static storage. It is a continuously evolving, breathing ecosystem. Through these background evolution algorithms, SmartMemory ensures the AI isn't just digitally hoarding data. Transient, episodic experiences from your active working memory are continuously evaluated, summarized, and crystallized into permanent semantic facts and Zettel networks. The memory literally cleans itself, organizes itself, and gets significantly smarter over time. So as we wrap up this explainer, I want to leave you with a question to chew on. Will your next AI just be a simple lookup tool or a continuously evolving mind? Consider how implementing this kind of dynamic hierarchical memory, complete with specialized cognitive types and background evolution, fundamentally transforms an AI. It moves from being a static database that you constantly have to prompt and remind into a true cognitive partner that actually grows right alongside you. The continuity problem is being solved, and for sure it's going to change how we interact with technology forever.